Welcome you all to lecture number 16 of this course. Now, before I proceed further, there are two announcements. The first one is related to your grading. Now, till now, I have taken one test and given two assignments. And I have seen your performance also in the two assignments and one test. Now, one thing I just want to make it clear that the marking which we are doing, that is relative in nature, that is not the absolute marking which we are doing. Let me repeat, we are doing relative marking, not the absolute marking. I think I'm clear to all of you. Now the second announcement is regarding the video of my last lecture, that is lecture number 15. Now I tried my level best and I tried several times to download the video of lecture number 15 from this Microsoft Teams, but I could not. And consequently, I could not put the video of lecture number 15 till now on the tray of Microsoft Teams. Okay. But PPT is already there. We have already put the PPT there on the tray of Microsoft Teams. Now I'll be requesting the TAs like Amit Kumar Das and Puspendra Gupta. Are you online, Amit and Puspendra?
Yes, sir.
So Amit and Puspendra, whenever you get time, okay, you have the permission. You also try to download the video of lecture number 15 if possible. Okay, because I tried several times, I failed. Okay, that happened only with the video of lecture number 15 only till now. Up to 14, I have downloaded and I have uploaded on the tray of Microsoft Teams. Lecture number 15, I could not do, although I tried several times. Okay, so I am requesting Amit and Puspendra, please try if you can do it. If you can do, you put it on the tray of Microsoft Teams. Okay. Now let us start with today's topic. Today I'm going to discuss with the applications of fuzzy sets. Now till now we have seen the meaning of fuzzy sets. We have defined like what do you mean by fuzzy sets, how to represent the fuzzy sets, like what are the different operations used in fuzzy sets. That means we have studied the grammar of fuzzy set in details. Now today we are going to discuss what are the possible applications of the concept of fuzzy sets or the grammar of fuzzy sets. Now to proceed further, let me tell you one thing, that the concept of fuzzy sets has been used to solve a variety of real world problems. Okay, if you see the literature, a huge literature is available. If a person wants to concentrate for his whole academic life on the fuzzy set and its application, so he or she can. Okay, it is such a huge. Now, as I told that this is not a course only on fuzzy sets or fuzzy logic, neither on optimization nor on neural network. So it is a course on soft computing. So I'm just going to give example of a few very important applications, and you will be astonished that real world problems can be very efficiently modeled using the concept of fuzzy sets. The uncertainty related to the real world problem can be very efficiently modeled using the concept of fuzzy sets. A few days ago, in fact, I delivered one invited lecture where I discussed the uncertainty modeling using the concept of fuzzy sets. But I do not know whether I'll be able to go up to that much of details so in this class. but I'll try my level best to give you the importance of using fuzzy sets to handle uncertainties in real world problems. Now, if you see the various applications of fuzzy sets has been used efficiently to develop the reasoning tool that is called the fuzzy reasoning tool, and very popularly this is known as the fuzzy logic controller or FLC. And the purpose of this reasoning tool is to establish the input output relationship of a process both in the forward as well as in the reverse direction. And all of you know why do you need the information both in the forward as well as in the reverse direction. The reason is very simple, because we want to automate that particular engineering system or engineering process. How does it work? I'm going to discuss in details after some time. Now then comes the concept of fuzzy clustering. Now this fuzzy clustering is done using the concept of similarity. So I'm just going to discuss in detail how to use the concept of similarity to do the clustering. That means your two similar data should belong to only one cluster, the same cluster, and two dissimilar data should belong to two different clusters. And I'll be taking some very practical example. I'm sure you people will be astonished, because knowingly or unknowingly, you use the principle of fuzzy clustering, but you do not know. But your brain actually does all such things. And while discussing the clustering, I'll be taking all such practical examples, and you'll be astonished to listen. Okay, that without knowing, you people are doing all such things. Okay, then comes your the fuzzy mathematical programming, fuzzy graph theory, fuzzy vision system, and others. Okay. For example, let me spend just 1 2 minutes on the fuzzy vision system. Once again, you will be astonished to know. As I mentioned, most probably in the last class, little bit, that there is a lot of uncertainties in our human vision system. The same person with the help of two eyes may not be able to get equal information at different two instants of time. Okay, it depends on his physical condition, like blood pressure, level of diabetes, and all such things. Those are all part and parcel now. Okay, now it depends on the mental state, mood. So everything is going to control. So it depends on the level of your vision system. The accuracy of your vision system depends on many parameters, and there is enough fuzziness in the vision system. Now, this fuzziness in vision system, actually, we try to model using the concept of fuzzy sets in your digital image processing, or the computer vision, or the robot vision. But I'll not be getting time to discuss all such things in this course. That I discuss actually in the course on robotics. Okay. Now, I think you know, some of you might be knowing my robotics NPTEL course is also going on side by side, and it is attended by more than 9,000 people throughout the world. And this is rerunning now. So if you are interested, you can also have a look through YouTube. So those video lectures also on robotics. Okay. So I'm not going for that now. So I'm going to concentrate on the reasoning tool, and I'll be solving some numerical example also, just to establish how does it look like and how does it work. So let me start with the principle of fuzzy logic controller, in short, that is called FLC, and that is also known as fuzzy reasoning tool. Now, what is the purpose? The purpose is to establish the input output relationship of a process of an engineering system, both in the forward as well as in the reverse direction. Now, before I discuss further let me tell you one fact. Now remember, although the name is fuzzy logic controller, okay, or fuzzy reasoning tool, there is no fuzziness on the output of the fuzzy logic controller. Please remember this particular statement because there is a lot of confusion among the people. Okay, so although this is called the fuzzy logic controller or fuzzy reasoning tool, once it has taken the decision, okay, there is no fuzziness on the decision. Now, this is called fuzzy logic controller or fuzzy reasoning tool because we use the concept of fuzzy sets to develop this fuzzy reasoning tool or fuzzy logic controller. But the output of the fuzzy logic controller or the output of fuzzy reasoning tool is crisp in nature. Please do not forget this fact. Now, the fuzzy logic controller or fuzzy reasoning tool that was developed by Mamdani and Esselian in the year 1974-75, long back. Now let me repeat the concept of fuzzy set that was reintroduced in 1965. Then after 9 or 10 years, the fuzzy logic controller or the fuzzy reasoning tool that was developed first by Mamdani and Esselian. Okay, now, the fuzzy logic controller was developed first by Mamdani and Esselian around 1974-75, but not by Professor Jade. Although Professor Jade is known as the father of fuzzy logic, who reintroduced the concept of your fuzzy sets. But fuzzy logic controller was first developed by Mamdani and Esselian. Now here I just want to give you one information and you people will be astonished to know most probably Mamdani received his degree, I think graduation degree from India, I think from Pune University. Okay. Now Mamdani and Esselian introduced the concept of fuzzy logic controller. Okay. And the performance of the fuzzy logic controller depends on the knowledge base, which consists of the database and rule base. If you remember, either in the first class, most probably on the first class or second class, okay, I introduced the concept of knowledge base, database, and rule base. Now here in this class, I'm just going to discuss in much more details. Okay, so already I've introduced those terms, so I'm not going to spend time on that. Now here I have put one comment. The performance of a fuzzy logic depends on the rule base and optimizing the database is a fine tuning process. Now this is the fact. This has been proved by me in my own PhD thesis also, long back. Okay. Now I'm just going to take one very practical example and you'll be astonished to listen that particular the example. Okay. Now supposing that you are going to appear a test at the end of the semester. That is not the case this time. Okay. Now in the test, supposing that there are 10 questions, okay, and I'm just going to compare the attitude of two students. Are you getting my point? Student one, so he has prepared the syllabus in such a way that he will be able to answer all 10 questions, okay, more or less correctly. And I have got a second student who has prepared only 50% of the content, but he has done it very minutely. Okay, he has gone to the depth, but he has covered only up to 50%, half, half of the course. So if he covers only up to 50%, there is a possibility that out of 10 questions, he will be able to answer only 5. Okay, it's a very hypothetical example. Now, the first student is able to answer all 10 questions, but he may not be able to answer 100% correctly. Okay. But the second student is able to answer only 5 questions out of 10, but he is in a position to give answer to all 5 questions very accurately. Are you getting my point? That means out of 100, the first student is going to get something might be 0 to 100, but the second student is going to get something between 0 to 50. Okay. Now, if the answer of the first student is more or less correct, what is your guess? Who is going to score more? Definitely the first student. Are you getting my point? So the first student is going to score more compared to the second student. What is the reason? The reason is this. The performance of an FLC largely depends on the rule base, and optimizing the database is a fine tuning process. What is rule base here? All the rules are available in his fuzzy logic in the head of that particular student, okay, related to 10 questions. So all the rules are there. So there is no chance of
Sir, you were
non-firing.
muted for a few seconds.
No, according to my symbol, there is no problem here. Can you hear me now?
Yes, sir.
Ah, ah, ah. Now, according to your the rule base of the first student, he or she is in a position to answer all the questions. So all the rules are available in his fuzzy logic controller or the head. But for the second student, some of the rules are missing. Related to question number 6 to 10, the rules are missing in his head, in his fuzzy logic controller. So there will be some no firing case. He is reading the question paper, but nothing is coming from his head, nothing is coming from his knowledge base, so that he or she can write the answer of that particular the question. Are you getting my point? So if you want to score a very good marks, you'll have to cover the whole portion and try to optimize your database in the sense, try to get the maximum information in your head related to the whole content. That means you'll have to learn in depth. Are you getting my point? So if you want to learn in depth, your database will be tuned. Okay. And if you have the overall information, your rule base contains all the rules. I hope you are very much clear that the example I took. Same is true for fuzzy logic controller. Okay. So with this information, let me tell you that if you see the literature, there are two forms of fuzzy logic controller or fuzzy reasoning tool. One is called is your the linguistic fuzzy modeling, and another is called the precise fuzzy modeling. Please try to understand very carefully. Okay, what do you mean by linguistic fuzzy modeling? In linguistic fuzzy modeling, we get high interpretability but low accuracy. Are you getting my point? Now I'm just going to define what do you mean by interpretability of a rule. Now let me take the same example which I took in the first class or the second class. Okay, that is your the temperature and humidity control with the help of an air conditioner of a lecture room. If you remember that particular example, there are many such input variables like your the temperature inside the room, humidity inside the room, temperature outside the room, humidity outside the room, number of people sitting in that particular lecture room. Okay, now I'm alone. I'm sitting alone. You people are not in front of me. Okay, now your then thermal conductivity of the wall and so on. And what is the output? Output is nothing but the angle of valve opening for the air conditioner. Okay. Now for simplicity, let me consider for this system, say there are two inputs and one output, and let me give the statement of a rule. The rule is as follows: if temperature is high and humidity is low, the valve opening of that particular air conditioner is medium. So this is a rule. Similarly, we have got a large number of the rules in the rule base. For example, say if I use four linguistic terms to represent the temperature, like low temperature, medium temperature, high temperature, very high temperature, and four other linguistic terms to represent the humidity. So we have got 4 multiplied by 4, 16 possible combination of inputs. So we have got 16 such rules in the rule base. Okay. So out of 16 rules, supposing that I'm reading it out, a particular rule. If temperature is low and humidity is medium, the angle of valve opening for the air conditioner is medium. The moment I read this particular rule, some control action is coming to my head. So depending on the input, so the moment I'm taking the output, at least some control action is coming to my head. So I'm able to understand the meaning of that particular the rule. So this particular the rule is interpretable or it is understandable. This is what we mean by the interpretability. I hope I'm clear to all of you. And what do you mean by an accuracy? All of you know that is the deviation between my calculated output and my target output. That is nothing but the precision or the accuracy. Okay. Now, if I get high interpretability, but unfortunately we will be getting low accuracy, that is called the linguistic fuzzy modeling. Example is your the Mamdani approach, okay, which I'm going to discuss in detail. Now, another classification is your the precise fuzzy modeling. Now, this is actually supported by low interpretability but high accuracy. And you know the meaning of interpretability. Now, low interpretability means in this particular approach, if I just read out one rule, no control action will enter to my head. For example, let me take the same example. If the temperature of the room is low and the humidity is medium, the angle of valve opening is a linear function of temperature and humidity. If I write something like this, okay, like the linear relationship could be something like this, like A naught plus A1 multiplied by temperature plus A2 multiplied by humidity. If the rule is something like this, what will happen? No control action is coming to my head. Okay, that is what we mean by the low interpretability. And here, the values of the coefficients, like your A0, A1, A2, those values will be determined using some optimization tool like genetic algorithm or some other tool, okay, with the help of some already collected training data. So there is every possibility you'll be getting the high accuracy. Okay. Now, example of this is your Takagi and Sugeno's approach, which also I'll be discussing in details. And that was developed around 1985. So Mamdani's approach was developed around 74-75, and Takagi and Sugeno's approach was developed around 1985. Okay. Now, after seeing this linguistic fuzzy modeling and precise fuzzy modeling, we also proposed one fuzzy reasoning tool. Myself, along with my students, we also proposed one fuzzy reasoning tool, which will be able to give a high interpretability as well as high accuracy. Okay. So we have already published, I think, in one international conference, so far as I can remember, and we are also trying for one journal paper. Okay, I think the revision has come. Okay, so we are working on it. Okay, so uh, our fuzzy reasoning tool is able to provide both high interpretability as well as your high accuracy. But that principle actually I'm not going to discuss so in this course. Now I'm just going to concentrate on the Mamdani approach of fuzzy reasoning tool or fuzzy logic controller. And you'll see that it is very simple. Okay. Now let me start from the very scratch and very beginning, and you'll understand that it is very simple. Now let me concentrate on this schematic view sort of thing. So here you concentrate on this particular block. Here I have written process to be controlled. Okay, supposing that the, the process to be controlled is nothing but the temperature and humidity control of this seminar room or the lecture room, okay, by controlling the valve opening of the air conditioner. That is the process to be controlled. So what we do is we try to identify some condition variables and action variables. Now these condition variables are nothing but the input variables which we have already mentioned, like temperature, humidity inside and outside of this seminar room. Okay. Then comes your number of people sitting in this particular room at a time, thermal conductivity and all such things. So these are all condition variables. What is the action variable? Action variable is nothing but the angle of valve opening for the air conditioner state. Okay. So this is actually a multi-input, one output. Okay. And in short, this multi-input and one output is actually your multi-input is MI and single output is SO. So this is known as MISO. MISO, multi-input and single output system. Okay. And these condition variables are also known as antecedent, which I'll be showing in the next slide. And these action variables, the output variables, are also known as consequent. Okay. And once you've got the condition variables or the input, so these input variables are allowed to pass through the database of this particular your the fuzzy reasoning tool. That means I have got the membership function distribution for each of the input variables. The moment I pass one set of input parameters, there is a possibility I'll be getting the membership function values corresponding to each of the input parameters. How to do it? I'm going to show you in details. Okay. That means corresponding to each of these particular input parameters. So I'll be getting the membership function values, and that is why this is known as the fuzzification module. Okay. And once you've got the membership values to this fuzzification module, now we'll concentrate on this fuzzy inference engine. I hope I've already taken this particular example in your first class or second class regarding the inference engine. Okay. Now, out of all the rules present in the rule base, and depending on the set of inputs, only a few will be activated or getting fired. Now, which rules are going to be fired? That is decided by your fuzzy inference engine. Let me take the same example which I took in the first class or the second class, because many of you joined after the second class, I hope. Okay. Now, supposing that throughout the semester you are prepared well and you are in the exam hall. And in the exam hall, you have got a question paper, say containing 10 questions, say. Now, the moment you got the question paper, you are going to concentrate on question number 1 because all 10 questions are to be answered. Okay. So you are going to concentrate on question number 1. If you have some information, so you'll be able to answer question number 1. How do you answer? The moment you are going to answer question number 1, might be once or twice you read out that question paper, question number 1, and on the answer script, you are going to give answer or reply to question number 1. Okay. The moment you read it out, there are several possibilities. Okay. Possibility 1, you may refer to my video lecture. Okay. Like you'll have to refer back to my video lecture or my PPT files or the textbook written by me, okay, or any other book or some source from internet, whatever may be, okay, to give answer to question number 1. Are you getting my point? Now, whenever you are going to give answer to question number 1, out of the whole knowledge base which you are going to keep in your mind, okay, only a few questions will be activated or fired. You have got all the information collected to my video lecture, by PPT files, by textbook, internet source, everything. You have studied everything. Okay. Now, based on that particular rule base which you have gathered in your brain, you are going to give reply to question number 1. That means if part of the rule base will be activated, okay, while giving answer to question number 1. Now, which rules are going to be fired? Which part of the knowledge base is going to be fired? That is decided by is your fuzzy inference engine. Let me take another very simple example. You see, I'm teaching many subjects, okay? But whenever you people or any other people ask me for some information, only a part of my knowledge base will be activated, okay, to give reply or answer to that particular the query. For example, say, if you ask me something on physiologic controller, and if I answer from robot dynamics, so I'm not doing my job. Are you getting my point? So, which part is to be activated to give answer or reply to that particular query? That has to be decided by my inference engine. Okay, that is the role of fuzzy inference engine. Now, I hope all of you have understood the role of fuzzy inference engine. Now, once the fuzzy inference engine has done its job, now corresponding to the fired rules, you'll be getting some output, and that particular output is nothing but the fuzzy fired output. Please switch off your audio and video. Now, corresponding to each of the fired rules, so I'll be getting some output, and that output is nothing but the fuzzy fired output. Now, supposing that we have got a number of fired rules, okay. Now, I'll have to consider all the fired rules together to find out what should be the combined output, and that particular combined output has to be very crisp in nature. For example, I'll show you the output for the fired rules which you get is in the form of some geometry, might be a truncated triangle, might be a trapezium, or might be a truncated, say, Gaussian distribution or truncated bell-shaped distribution, something like this. Okay, so directly we cannot use it for controlling the angle of valve opening for the air conditioner. So what you'll have to do is you'll have to go for defuzzification. And if you go for the defuzzification module, as an output, you'll be getting the crisp value for the angle of the valve opening. And that particular crisp output we are going to use for controlling the temperature and humidity of this particular the room. Okay, this is the way actually the Mamdani approach of fuzzy reasoning tool works. Now here I have written an FLC consists of 4 modules. like rule base, inference engine, fuzzification module, and defuzzification module. I hope I'm clear to all of you. But if there is any doubt, definitely I'll give you some time at the end of today's discussion and I'll try my level best to clear your doubts. You just wait a little bit. Now, steps involved in the working cycle of fuzzy logic controller. Whatever I have already mentioned, those things only I have written it here. You identify the condition and action variables. Condition variables are known as antecedent. Action variables are known as consequent. Okay. And we'll have to go for fuzzification. This I've already discussed. Then comes inference engine. I have discussed in details. Then comes the deep fuzzification. I have given you introduction, but I will be discussing in much more details. Okay. Now, supposing that out of all the rules present in your rule base in your head, for simplicity, say only two rules are going to be fired. For simplicity, I'm going to consider only two rules, only two fired rules. So fired rule 1 is something like this. If S1 is A1 and now remember, here I am using capital A and D. There is a purpose. Don't use small a and d here in Mamdani approach. I am discussing the Mamdani approach of fuzzy reasoning tool, where and is not the conjunction and, that is the operator and, that has to be written in capital. Please do not make this mistake being one of my students. Okay, I've seen this mistake is done by many people, but that is wrong. So the rule is if S1 is A1 and S2 is B1, then A prime is C1. This is the rule. So what we do is for S1, so this is the membership function distribution for A1. For S2, this is the membership function distribution for B1. And A prime, this is the membership function distribution for C1. Okay, so this indicates the first fired rule. The second fired rule, if S1 is A2, this is a membership function distribution for A2, and S2 is B2, this is the membership function distribution for B2, then F prime is C2, this is the membership function distribution for C2. Okay, so this is the second rule, second fired rule. Now I've got two such fired rules and I'm going to pass one set of inputs, that means one set of temperature and humidity. Okay. Now temperature is denoted by the S1 star. Okay. And humidity is denoted by say S2 star. The moment I'm passing this S1 star and S2 star, how to find out the output of this particular, the two fired rules, that I'm going to discuss. Now, supposing that I'm going to pass one set of S1 star and S2 star. The moment I'm passing S1 star, that is the temperature corresponding to A1, so I'll be getting this much of mu. Then corresponding to your S2 star, I'll be getting this much of mu. Now please stop your audio and video. I'll give you the opportunity to talk to me at the end. Please stop your audio and video. Srilekha, please stop your audio and video. Now, the moment I'm passing S1 star and S2 star, okay, so I'll be getting what? Now, please do not disturb me, Siladitya. S1 star and S2 star, if I'm passing, please do not disturb me. Siladitya Bag, please do not disturb me now. Let me finish it. After that, I'll listen to you. Now, the moment I'm passing S1 star and S2 star, so I'll be getting. Now, let me stop here because it has been, my PPT has been changed.